we are live.
Good morning, everyone. I am Ranisha Mistry, lecturer, Civil Engineering Department, Parul Polytechnic Institute, Parul University. I welcome you all in today's webinar on challenges for civil engineers in developing countries on behalf of Parul Polytechnic Institute, Parul University. Our today's speaker is Mr. Parth Wagane. He is currently working as a senior engineer in Aston Avenue. He has more than 9 years of experience in construction industries, and he has completed number of construction projects throughout his career. I welcome you, sir, and I request you to start the session.
Thank you, madam, for the introduction.
Welcome,
today's
sir.
my topic is challenges for civil engineer of developing countries. First of all, I will introduce about engineering, but let me first inform about the topic. Generally, developing countries are having many limitations which developed countries don't have. The main problem is finance always, as developing countries don't have enough budget, and otherwise we can say that budget limitations. So more optimization require regarding any engineering development or any type of other development. So let me start with the introduction of engineering. First of all, what is engineering? Most of the structures in our history are made without any engineer. So why we required field of engineering? So according to my thought process and opinion, engineering is for optimization. To make any building, if we say about particular civil engineering, for the particular life and particular strength. So we design generally building according to our requirement and according to life. For example, we can say that in our field we may construct temporary office, which we require only for 1 or 2 years. So we don't follow any codal provisions over there, because we know that we are going to destroy within 2 years only. Like that, engineering is optimization. And particular I go, then there is a photo in the slide. I took example of India only. I found this place as India's oldest exposed structure. So which was built almost 2300 years back, and which is already there even today. So and that was at that time, engineering was also not a field. Even before engineers, mathematicians were there to design buildings, but at that time even mathematicians were also not there for that purpose. So that structure was made to last as long as possible. That's why it is also available even today. But if we analyze that, even we cannot find more than 100-year-old building in our city. This one is our just completed project, which we designed for 50 years, as generally today's buildings are designed. And I'm sure that it will not complete even the running century, which is 21st century, because we don't even plan to stand it for more than 60 years, as the design life is 50 years. Even it will require some maintenance also. Otherwise, early demolition may also require. It was happened even Vadodara also, that 32-year old building was got order for demolition from our municipal corporation. And there can be so many reasons of that. One is at the time of construction some leaking, and other can be regular means irregular maintenance. Maintenance is also so important, as I take one example that somewhere leakage is there and which is reaching to reinforcement of the building, then corrosion will start, and if we don't stop that, then it will slowly progress, and which will demolish the structure earlier than the design. So that is also so important part. Which I already mentioned, as the those historic buildings are standing because it was designed to last as long as possible. Which I haven't showed here is, if we see pyramid in Egypt, which are, I think, oldest structure, exposed structure among the history, or older structure than that was covered in any soil or somewhere, because that's why they survived. But these pyramid and the stupa of our India was the example which was exposed from the date that was built. So what is engineering? Basically applying knowledge to give the best for the means for the requirement and situation. So like I informed that we build temporary structures like our site office, and sometimes we even build structure temporary for few days. So the requirement means we need to design according to requirement. Even at that time don't require any structure engineers for temporary structures. At the other end, when we built some building like we just completed, we require structure design, even structure stability certificate, means all type of authorized certification for building life and what we design. Even structure engineers are also having license from government authorities for this type of designing. Now let me come to the main topic, which is type of challenges which engineers face in developing country. So ours is developing country. If we analyze that developing countries are on the similar northern and hemisphere, as weather are even similar in those developing countries, and that is if we see is favorable for construction conditions, where in developed countries weather are more harsh and construction conditions are even more harsh. So if we think, then challenges are less than developed country for the engineers of developing country, but problems are even different in developing countries. As I said already, the budget is the issue, and another issue is we have provisions for construction which are not as hard as developed countries. As here in our country, buildings are built without engineers also. Only those people build some buildings who have only experience, and only on-site involvements are not of any engineer who have certification. So due to that, some part which only study covers, and those people cannot understand. And the challenge of the engineer is that to tackle and follow the standards which are already covered in study, but we rarely see in the field where engineers are not available at site. First of all, challenges for engineer in office means other than field, which is not part of my main topic. I am going to cover on field challenges mainly, so we are not going in deep in that topic. But if I say that even those people also coordinate with non-technical peoples which don't have their study background as engineer, and to coordinate with them is also a little bit tough in that case. Let's go on the main topic for engineers on site. So engineers on site have so many challenges, particular in our country, which is developing. So let us go one by one. Which I already mentioned, that dealing with non-technical people for technical things. So what happens is, let me go one by one for point by point. First of all, let us take one example: removal of disturbed soil. Generally, people think on site that we should lay footing on the same level. As you see that these excavators, these are very large. Even the dent of this excavator is also 4 to 5 inch in length. So while excavating, you can see at least 2 to 3 inch variation in excavation if the driver is very experienced. So generally on site, what happens? People excavate, and after that they check the level. In case of 2-3 inch level variation, they refill that 2 to 3 inch soil to make all the level same, which is a perfectly wrong practice. We need to remove just disturbed soil, because construction of a building on disturbed soil may occur some settlement. So if at the time of different settlement, where one footing is on disturbed soil and one is on undisturbed soil, the settlement will be different. In that case, structure may have some extra stress which are not even designed for that building, which may cause problems in long term, and sometimes in short period also. So how one footing should be in a particular method? So another slide is there. This one is showing at different level of soil footings, but I am taking this as just example. If and this is showing so much difference of level, which is approximately 2 to 3 feet, as you can see, but we can make this difference for 2 to 3 inch or 6 inch. Generally, people on site don't go for that difference of level. The reason behind that is they need to calculate steel cutting length and bending length and grading of that different length of bars, and that is very difficult to manage. So due to that, to avoid that difficulties, they avoid these type of different level footings, which is a wrong practice. Let me go for another issue. People which are not in from technical background think that appearance of concrete is a proof of strength, which is perfectly wrong. It might be possible that appearance is good and strength is also good, but it is not always true. As you can see in this slide, one is exposed concrete, which is having very good finishing, but we cannot figure out strength from that appearance. And it might be possible that the good appearance concrete may have less strength than the other photo of the concrete, which is not as good as the first one. We have so many tests which are non-destructive tests, like ultrasonic wave rebound hammer, by which we can figure out at some extent uh, that what is the strength of the concrete on site after casting, means after final setting time is over. But the main thing is, at the time of construction we should know that how we can make concrete and what are the criterias by which we can give best result, means the optimum result. Means with the best content of cement we should give the best result of the concrete strength, uh, which is actually mixed design concept. We have one IS code for that also, which is IS 10262, which is mixed design code. Generally, diploma or degree engineering students are not familiar with that because that is not part of their course. How to maintain strength of concrete in that situation? So generally the photo is there. We have situation on site like that where only illiterate people are making concrete, and very rare time engineer is available on that place to maintain the things. Even the problem is there, to make work easier they change the water cement ratio, which is the main thing for the concrete to get strength. And by adding more water, workability increases, and due to that working gets easier for laborers, and that's why they used to do that, and in that is in their practice. So engineer at site should know what is proper, then only they can restrict them doing the wrong practice. First of all, we need to know what should be, then we can make people to follow the standards. So first of all, we should understand the standards. So for that, we should understand what is concrete, and for if we understand what is concrete, then only we can make the proper concrete. So first of all, concrete is void filling mechanism. So maximum size of aggregate is 20 mm in concrete. In general concrete, I am saying, not in the particular structures like dams, where that aggregate size may go higher into to 60 mm, up to 60 mm also. So we just see if normal concrete, which is regularly used, 20 mm is maximum aggregate size. So 20 mm aggregate are there in a one bucket, then some voids are also there. So that voids are filled by 10 mm aggregates, and voids of 10 mm aggregates are filled with sand. Voids of sand are filled with cement, and voids of cement are generally filled with water when we make concrete. But after that, after cement settlement, those voids are also filled with the cement process. So at the end, we have very rare voids. In case of Portland Pozzolana cement, means PPC cement, we have fly ash also available there, which fills those voids properly, and which gives better strength result in that case. So the photo is showing that how voids are filling. Generally, this happens in the actual concrete. The perfect void fillings, which we imagine, are not happening everywhere, and little bit segregation or some practical issue may occur, and final result is as shown in picture. But this one is also good concrete. Otherwise, the section are having some voids which are not there in this photo. So to know that quality of concrete, we should take core of our casted concrete, and if we analyze that core, then we can understand that what is actual concreting, and was that proper or not. And we can test their core cylinder in laboratory to know actual strength, which is not perfectly non-destructive test, as we take one core out of the concrete. The other point is water cement ratio. It should be maintained as per specifications. However, practically on site, perfect maintain perfect ratio is not possible, as weighing facilities are not also there, and labors manually pour the water, so we cannot perfectly imagine that, or we cannot figure out how much water is going there. But by checking the concrete and its appearance, we can with experience can understand how much the water is there and it is proper or not. For that, proper mixing to make concrete is also important. Concrete should be cohesive. So according the guidelines, after pouring in mixture machine all the materials, it should mix at least for 2 minutes. So 2 minutes of mixing will make concrete cohesive. If we don't mix for 2 minutes, then what happens that to make it proper, to show the proper mix, laborers add more water, and that makes similar appearance, and which we think the water content is proper, but actually the case is not that, and that results in extra water comes after pouring over the surface or under the surface. Means we can see some dropping below the former, or after finishing we can see extra water coming out from the concrete on the surface, which is not the proper practice. Quality of raw material is also plays important role. Particular, I say that aggregates should not be flaky and proper in size and uniform size, because if size is not uniform, then concrete mix may vary, and we need to change the proportion again and again, which will not give the constant result of the strength. And in case of raw material, sand is also playing very important role. Cement is binding material which binds all the aggregates from its surface. So if sand is having more silt content, at that condition, surface area will increase, and as much as the surface area, the strength of the concrete will go lower. So we cannot see in fresh concrete what is the content of silt in the sand, but we have some methods to figure it out on site. which I will show in one video later. This one is slump test instrument. We have some test. Actually, for fresh concrete we have this test only with instrument to figure out perfect concrete, which is slump test. I am not going deep in the slump test, which is already available in on many ways. Even you can find it out on YouTube by just searching slump test and get more information. Even codes are also available to check how to understand the slump test. The main problem on site is we don't have most of the case instrument of this slump test on site. So what are the solution for that? So experience with instrument, which means if you are having experience of few years, or I can say the multiple concreting on site and multiple times of slump tests, then you can understand with comparison with the slump test and appearance of the concrete and the mixing time, that what how the proper concrete mix looks like. So for that experience you should have experience with instrument on site. So which I already have that experience. So I can judge the concrete after that means after mixing, and when it comes on the pouring location. And many people are there, even I am engineer, but few people are there which are not engineer, but who knows how the concrete should be, and they can judge the concrete on site at the time of pouring. And we should search some method. I'm showing one video. I'm going to show one video which is from Ultratech, and which can show one field test. I will take a moment to load the video. Video is visible to everyone?
Yes, sir. It is visible.
Okay, thank you. This one is field test for cohesion of concrete. So let me explain as the audio will not be available from the video to everyone. We should take a little sample of the concrete, and as shown in this video, like this, we should take it in hand and make a ball of that concrete, means from the fresh concrete. And it should be a ball, means if it is not making a ball like this, then the concrete proportion is not proper, or some problem is there. Most of the case segregation or high water cement ratio is the problem in that case. If the ball we cannot make ball from this means fresh concrete. After that, we should take it in hand and throw up to 6 inch of height, 6 to 8 inch of height, and it should be as it is. It is shown in the video. If any crack appears or segregation or any core segregate comes out from the ball, then the concrete mix is not proper, means the concrete is not cohesive. So this is shown that if the concrete is not proper, then this type of cracks and core segregate can come out. So the shown ball is not a proper cohesive concrete. And if the if concrete looks even worse than this, then more problem is there. Even we can say that our mixing is not proper, means ratio of the aggregates are not even proper. Then another thing, if we throw it like this around 2 feet of height, it should have cracks. The last time I said that it should not have cracks. This time it should have cracks. As we increase the height from 6 to 8 inch to 1.5 to 2 feet. So if it cracks like this and have minor cracks, then the concrete is cohesive. This is the test particularly for cracking, means if we check only one thing, then it is not enough. The other height, means up to 1.5 to 2 feet height, this test is also important, because the ball can be as it is, as shown in the first case. Even the concrete is not cohesive and have less water content than required. So this test is for that. The first is showing that if the water is higher or not, and the second is showing if water is lower and or not. So after these both test, we can say that water and aggregate proportions are okay. So this one is the test which we don't require any instrument at site. And generally concrete looks like this, where you can see no segregation. This is the first, around 6 to 8 inch height, and this one is the second one, which is 1.5 to 2 feet of height. Let us move to our main slide again. Okay, so next point is curing. You can see 4 photos in the slide. First is ponding, which is the right method, but the problem with that is generally we have hurry to get ahead in construction schedule because we have some deadlines also. So labor cannot work in this type of ponding. They have some their problems and it becomes hard to work in that water. So they avoid having water, and we want to have that ponding for the strength. So at that condition some issues occurs. So second one is the thing which generally occurs in developed country. They are spraying some chemical to lock the existing water of the concrete in the concrete, which is one type of curing. So it generally people think that adding extra water is the only type of curing, but that's not true. Locking the existing water in the concrete is enough for curing. In case of normal structures which don't have so much thickness, in case of dams, things differs, as heat also becomes actually see when cement settles and gains the strength, heat releases, which is called heat of hydration. So at the time of hydration process, heat releases. So the third is column is covered with jute fabric, which is the proper method. And the fourth is nothing is covered on the column, just one person is pouring water on the column, which is not the proper method, as that water will not last more than few minutes. So we need water for long period, either by locking or by adding, which is already vaporized. So the proper method is which is in the third photo, where one person is pouring water and the cloth is wrapped on the column, which will keep the moisture for long term. But the problem is that method is also rarely available on general construction sites, because workers want to work further on that area, and this covering makes problem for them. Even we can say that some people who are not having engineering background avoids as they think that thing as a waste of money by doing those things and maintaining those things, which is not true. Let me come again on structural point, where some things are lacking and people makes mistake. That is lapping zone. Generally, steel comes in the length of 40 feet. So we don't have perfect size on site, and we have sometimes some wastage of steel. To avoid that wastage, people try to lap the steel. That is I'm saying in case of beam, not the column, because column don't have any option. I will come to that point later on. So in the beam, lapping zone is having some limitations. So next slide is regarding that. This is showing bending moment diagram of a simply supported beam. Actually, I can say that beam with having end supports and restraint at the end of the beam for moment. And these type of beams are there in regular structures. Other beams which you learn in college are not in regular practice. One other thing is cantilever, which is in regular practice, but cantilevers are not allowed to have lapping in top reinforcement, which is already mentioned always in the structural drawing. So studying drawing with the instruction which are shown in drawings are very important before execution of the work. So center of the lapping and point of contraflexor should overlap. So how lapping should be is written over there. So what is point of contraflexor? Point of contraflexor is the point where bending moment is zero. As you can see in this bending moment diagram, where the level of beam and the bending moment diagram, two things overlaps, means this point which I am showing with the cursor and the similar point here, both are point of contraflexor. So center of the lap and the point of contraflexor should overlap. This should happen at the portion where tension is there. So I think that deep designing part is not of the in diploma syllabus. So I am not going much deeper in that. In case of column, we have very limited spacing for overlapping, and in column definitely we cannot go uh, uh, ahead without lapping, which may occur in the thing in beams. So if h is height from beam top to next beam bottom, beam top is definitely slab top in any case, because beam and slab are always combined in general structures. So beam top to next beam bottom is height, which we say h. Then leaving h by 4 both the end, the rest h by 2 height is lapping zone. And lapping should not be in single layer, which I will show in another slide. So lapping, the first photo is here showing improper lapping, as all the lap is at the same place, which is not proper practice, as that portion becomes weaker portion. Lap should be like this, alternate, means staggered lapping, uh, due to which some continue steel goes there, due to which any particular portion don't become weak. General side, the wrong practice occurs that the lower h by 4 or h by 2 are having most of the lappings, as worker can just add another steel by standing over there. Sometime that become that happens due to avoid wastage. Actually that is not wastage, that is utilization of the steel. And we can plan from the beginning to avoid wastage, and we can get the best results. Another point is ring at beam and column junction. Ring means stirrups. Stirrups should be there in beam and column both, but at the junction we cannot add both stirrups, so we can add only one stirrup. So which stirrup should be there? So that is the stirrup of column which should be there. And this one was the one of the major reason of collapse in 2001 earthquake, when buildings, so many buildings were collapsed in Ahmedabad, Bhuj, and in many places of the Gujarat. So after analyzing those events, one of the reason come out, as people were avoiding beam column junction ring, and that stirrup was playing major role at the time of earthquake. How it plays the role is a different matter, and that is, I can say that if someone will go in study of MTech structure, then can go deep in that, and it is not part of a diploma or a degree study generally. Another general point is dealing with workers, which you will go on the field. You will be having this much knowledge before going to the site and dealing with people working on site. If you are new on the site, keep learning attitude. So with learning attitude, you can learn how to implement things which you learned in the college. So definitely college knowledge is also so much important. You will face some people which are wealthy and having more experience on site, and will say that your knowledge of study is not important, but that's perfectly wrong thing, because they only have knowledge what they can see, but they don't have knowledge of the things which they cannot see. For example, we know that after having improper water cement ratio, how it affects to the strength of the concrete. But a person who don't have any knowledge of study of civil engineering may not understand that thing. And most of the case, what happens at construction site in developed countries, that we need to compromise some way. So as per our study, we cannot implement the perfect thing on site. In that case, we can choose the better way if we cannot go for the best way. So if we cannot manage water cement ratio perfectly, this is I'm taking example of one thing. We should know that in what extent we can go for perfection in water cement ratio. So we can go for better way rather than leaving the things as it is going on the laborers which are not literate even and don't know what it should be and even don't care for that things. My main topic is over now here. Other topics regarding RCC frame structure type of building which I have experience of, I can say just I am going through the headings only. One is plumbing. In that case, leakage problems and pressure problem occurs. The pressure problem is, for example, you have insufficient pressure. Like if you don't have enough pressure in the toilet, then flushing can be the problem. In case of the flush cock or metropole type of flushing devices. In flush tank type of device, that is not a problem. Another is waterproofing. In waterproofing, the main problem is why it requires, where it requires, and how it should be done are the main topics. So if I say how, then in short I can say that water should not stag anywhere. So waterproofing should be like that, having sufficient slope that if water from anywhere comes on the waterproofing, it should run away and drain out. Another thing is wall cracks. Our general buildings are having partition walls which have thickness of 5 to 6 inches with plaster. So they get cracks most of the times. So reason of crack is very important for the solution of the crack. Another is tiles and stonework. So different type of tiles and different type of stones. There are different methods and different type of binding materials other than cement also are there. And the last is laboratory testing of materials. So all the materials have some specifications and we can test them in laboratory. Most of the times finishing materials are not tested at the laboratory in general sites, and which is not much required also. And I don't have experience of finishing material testing in laboratory. And at the last, if we will be there, then the work will go ahead. So importance of helmet and safety of an engineer at site is also very important. Even safety of labor is also important. So one should know importance of their safety. So I can say that you should understand your safety first, then you can say it to others. Thank you so much.
Thank you so much, sir. The session was very informative and you have covered all the possible things. So I hope this webinar helps our students to introduce real world engineering practices. So once again, I would like to thank you and for giving your valuable time and from your busy schedule and joining us today. Thank you, sir. And there are a few questions from the student side. So one question is, sir, how can we handle all those construction challenges that you have mentioned, or how you handle those challenges?
See, for that, I can say that we should have enough knowledge of study. So we should know what should be there. So if we don't know what should be, then we cannot solve the problem. I can say a small example. For one person is having fever, but what is work of doctor? Doctor analyzes that reason of the fever, and after then gives us medicine for that particular reason, not for the fever. So like that, we should know the what should be, then we can face the problem. And main thing is experience. If we don't have learning attitude, and we don't focus on the things which are going on, then we cannot solve the problems. And keep one thing particular regarding this question. Keep one thing in mind, that we can learn from anyone. For example, I have experience of 2014. One person of means the lowest labor on the site teach me one little thing, which was not very big, but in that thing I can say that he was more knowledgeable than me at that time.
Okay, sir, according to you, what are the main reasons for the failure of any construction?
If we say the failure of under construction, then definitely lackings are there. And if we say after some time, for example, if we design the structure for 50 years, and we get notice from a corporation to demolish it after 30 years or 35 years, then two problems can be there. Mainly, one is at the time of construction, some practice are gone wrong. For example, I said that water cement ratio will not show the result instantly. It will start showing result after a few years. I can say that not before even 10 years. So higher water cement ratio will lead to low strength. And generally, if those students who have gone through the designing point, we generally design RCC which are under reinforced. So at that time, building should reinforcement should fail, and it give warning to vacant the building before it collapse. So if concrete strength goes as low as it should not be, then the structure becomes over reinforced, and at that time it may collapse if any earthquake event occurs. So that is the problem at the time of construction. If I say after construction, then I can say that if some event occurs due to which minor damage occurs. For example, one person try to drill in a beam or go for core cutting. After that, regular water leakage is also there, which reaches that location and reaches to the main steel or stirrups. Then corrosion will start, and that corrosion will lead to structural damage after long period. So that one is also reason of failure.
Okay, and sir, one last question is lack of skilled workers is a challenge?
Definitely, that one is a very big challenge, and we don't have even solution of that. So we should make system in which from those people we can get the best work. So what happens generally, if we say, I take example of the lowest skilled people. For example, we have one concrete mix in which we have a proportion of means generally we have actually can say those tagaris, so in which we have coarse aggregate and sand to pour in the mixer machine. So we count number of that. So those people counts that how much they are working, and to reduce their working they can change proportion also. For example, one person is pouring five number of sand, and another is pouring six number of coarse aggregate or eight number of coarse aggregate. Then that is the proper proportion at that time. Then even just jealousy of the person pouring coarse aggregate may change the proportion, and for that we need to make the system, means one person or supervisor or any engineer should be there to check that continuously, to make proper proportion. So unskilled labors are also definitely a problem, but we should figure out a solution, and should make some system to uh, make solution of that. Means another solution is like I can say that ready mix concrete. Even some ready mix concrete provider are giving concrete in bags which are far more costlier than the site mix. So if we we are building that type of structure where we cannot compromise little bit of strength, then we can go for that. Otherwise we can go for manual mix, and can analyze and supervise the construction activity for the solution.
Okay, that is all for my side, sir. And once again, thank you so much for taking out your time and be joining us today. Thank you, sir.
And I will also like to thank you, madam, and your all the team and Parul University for giving opportunity to conduct this session, and to share my knowledge with the students of your college.
You're welcome, sir.
Okay, thank you.
So you can leave the meeting.